Hello viewers, now we are going to discuss the continuation of the series type problems in inverse trigonometric functions. Already two problems we discussed in previous lecture. Now you see that one more question in this model. All of you see this one. Here what is that given question? So the given question will be tan inverse of 4 by 7 plus tan inverse of 4 by 19 plus tan inverse of 4 by 67 plus and so on to infinity. So that means it will be represented sum of the infinite terms. So sum of the infinite terms means what we discussed in the last video. First you have to find the sum of the n terms. So now you write it that what is that given terms? Given terms will be tan inverse of this one will be 4 by 7, tan inverse of 4 by 7 plus the next one is the tan inverse of 4 by 19, 4 by 19, say plus tan inverse of 4 by 39, tan inverse of 4 by 39, next plus tan inverse of 4 by 67, tan inverse of 4 by 67 plus and so on to infinity. So this one is the given series. This is the infinite series. Sum of the infinite terms. Sum of the infinite terms will be represented this one. By observing this series, numerator value is in all the terms will be the 4. So its a numerator is the same. Only denominator is the different. So how can we write the denominator value? See, you can say that 7 you can write that 4 into 1 whole square plus 3. 4 into 1 whole square plus 3. And 19 you can write that 4 into this one is the 2 square plus 3. Right? And 39 you can write as that 4 into 3 square plus 3. 3 square plus 3. So what is that general term? So general term will be nothing but you can write that TR. General term will be TR is equals to tan inverse of 4 whole divided by 4 into r square plus 3. 4 into r square plus 3. This one is the general term. So now after finding the general term, first we will find that sum of n terms. How will you find the sum of the n terms? So now you apply the sigma to the general term, you can find the sum of the n terms. First you will be calculate this one, you will be simplify this one. Here this one we can write that a tan inverse of, divide numerator and denominator with a 4, 1 whole divided by this one is that r square plus 3 by 4. This one is that 3 by 4. Now after this one, tan inverse of 1 whole divided by 3 by 4 you can write 1 minus 1 by 4. So this one will be 1 plus r square minus 1 by 4. 1 by 4 will be 1 by 2 whole square. Okay. So now in this you take r square minus 1 by 4. You know r square minus 1 by 4 you can write as r plus 1 by 2 into r minus 1 by 2. R minus 1 by 2. So now after this one, you see here is a by subtracting these two. By subtracting these two. So now you will be get this value will be r plus 1 by 2 minus of r minus 1 by 2 is that 1. So in this tan inverse of numerator value 1 can be expressed as tan inverse of this one will be r plus 1 by 2. R plus 1 by 2 minus of r minus 1 by 2 whole divided by 1 plus r plus 1 by 2 into r minus 1 by 2, r minus 1 by 2, right? So this is, now this expression is in which form? This one will be tan inverse of x minus y by 1 plus x into y. So now you can write that tan inverse of r plus 1 by 2, 1 by 2, okay, minus tan inverse of r minus 1 by 2, r minus 1 by 2. So this one is the simplified value. Okay, the general term is, after simplifying you will get this one. Now sum of the n terms. Sum of the n terms means what? Sigma tr. So r value is nothing but 1 to n. This one is that sum of the n terms. Sum of the n terms. This one will be equals to sigma. See, sigma means sum of the terms by substituting r is equals to 1 to n. So now you substitute that first r is equals to 1 in this value. R is equals to 1 in this value. Tan inverse of 1 plus 1 by 2 is nothing but 3 by 2. Okay, minus tan inverse of 1 minus 1 by 2, that is that 1 by 2. So this is that first term after substituting the r is equals to 1, plus next r is equals to 2, substitute in this value tan inverse of 2 plus 1 by 2, that is that 5 by 2, minus tan inverse of 2 minus 1 by 2, that value will be 3 by 2, tan inverse of 3 by 2. This is the second term. Okay, plus next tan inverse r is equals to 3, you substitute. If you write that r is equals to 3 in this value, tan inverse of 3 plus 1 by 2, 3 plus 1 by 2 will be 7 by 2, minus tan inverse of 3 minus 1 by 2, that value will be 5 by 2. That value is a 5 by 2. Okay, plus here this is a plus, and so on and so on. So now the last term will be tan inverse of, here is the last term, plus tan inverse of r n plus 1 by 2, n plus 1 by 2, minus tan inverse of n minus 1 by 2, n minus 1 by 2. So this one is the different terms after substituting r is equals to 1, 2, 3 and so on to n. Now after that, by observing this one, here you see that tan inverse 3 by 2 plus tan inverse 3 by 2 minus tan inverse 3 by 2 cancel, plus tan inverse 5 by 2 minus tan inverse 5 by 2 plus tan inverse 7 by 2 cancel, and next the last term, this one will be cancelled. What are the remaining terms in this one? In the last term, tan inverse of n plus 1 by 2, and in the first term minus tan inverse of 1 by 2. So that means you can write what is that final value, resultant value, tan inverse of n plus 1 by 2 minus tan inverse of 1 by 2, tan inverse of 1 by 2. So this is that value. Now you want that question is sum of the infinite terms. Sum of the infinite terms means that will be represented as infinitive. This one we can write that limit n tends to infinitive Sn, that is equals to, substitute n is equals to infinitive in that above result, tan inverse of infinitive plus 1 by 2 will be infinitive. Okay, so minus tan inverse of 1 by 2, tan inverse of 1 by 2. You know tan inverse infinitive will be pi by 2. This value is that pi by 2, minus tan inverse of, this value will be 1 by 2. So this is a 1 result. Now this one we can write that pi by 2 minus tan inverse 1 by 2, you can write that a cot inverse of 2. Which one? How you can write this one? Since we know the formula, tan inverse of 1 by x is equals to cot inverse of x. Cot inverse of x. So by using this formula, you can write this one. But in the given question, in this one, the options are not directly in this form. So which one are the given options? So here these are the given options. Now one by one options, by verifying you can write this one will be, you say here is that first one by one options you verify that one. How you can be verify this one? You simplify that first the option 1. First you simplify tan inverse 1 by 2 plus tan inverse of 1 by 5, 1 by 3. Tan inverse 1 by 2 plus tan inverse 1 by 3, this value will be pi by 4. Pi by 4 plus 1 by 2, that is equals to tan inverse 1 is nothing but pi by 4. So this value will be pi by 4 plus pi by 4. Pi by 4 plus pi by 4. So this value answer will be what? Pi by 2. And next see the second one. Here this value will be, you can write that tan inverse of tan inverse 1 plus cot inverse of 3. Cot inverse of 3. Now you write this one is the tan inverse 1. Okay, tan inverse 1 plus tan inverse 1 by 3. Tan inverse 1 by 3. Now tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y, formula is that what? Tan inverse of x plus y by 1 minus x into y. So tan inverse of 1 plus 1 plus 1 by 3 whole divided by 1 minus x into y is that 1 by 3. So this value will be equals to tan inverse of 4 by 2. Tan inverse of 4 by 2 is the tan inverse of 2. Tan inverse of 2 will be equals to, you can write that pi by 2 minus cot inverse of 2. Pi by 2 minus cot inverse of 2. So now you see here the final result will be, final, already you got it. This one will be pi by 2 minus cot inverse of 2. You have this result. So now this one will be, this result will be equal to which option? That is that option 2 is the correct answer. So your right answer will be option 2 is the correct answer. I hope that everyone is clear this problem. Now in the same model, no need to go the other options. Now we will discuss that some other questions. Next question. You see what is that next question? See the next question. Next question is that it is the advanced problem, previous year advanced question. Now here this one will be sigma n is equals to 1 to 23 cot inverse of 1 plus sigma k is equals to 1 to n 2k. So first I will be simplify this sigma value, this one sigma k is equals to 1 to n. First we will be simplify this value, right? So here only we will do this value. Sigma n is k is equals to 1 to n means sigma 2k. Sigma 2k means that is equals to 2 into sigma k, right? Now that is equals to 2 into k value 1 to n means sigma k is the sum of the n natural numbers. That means n into n plus 1 whole divided by 2. Now here 2 and 2 will be cancelled. That is equals to, this value will be n square plus n. Now substitute this value in the given question. So first of all you will be find out that cot inverse of, so here the first you will be find out that cot inverse cot inverse of, here the question is 1 plus sigma k is equals to 1 to n 2k. Sigma k is equals to 1 to n 2k value n square plus n. So you can write this value is that 1 plus sigma k is equals to 1 to n 2k. This value you replace in this one, that is equals to cot inverse of this is that 1 plus n square plus n. So 1 plus n square. Now by using the fundamental formula, cot inverse x is equals to tan inverse of 1 by x. So you can write this value will be tan inverse of 1 whole divided by 1 plus n square. So n plus n square, you take that n into n plus 1, you can write it. So I hope this one is clear. Now you see how can we convert this one into our standard result. Numerator 1, you can write that tan inverse of this value will be n plus 1 minus n whole divided by, so plus n and minus n after the cancel, you will get that only 1 by 1 plus n plus 1 into n plus 1 into n. So now here the numerator is nothing but this one n plus 1, you assume that x, n is that y, tan inverse of x minus y by 1 plus x into y. You know this one will be tan inverse x minus tan inverse y. So tan inverse of n plus 1 minus tan inverse of n. So here the result will be this one. Okay, after you see the question, sigma k is equals to n is equals to 1 to 23. N is equals to 1 to 23. So sigma n is equals to 1 to 23. Sigma n is equals to 1 to 23. This one will be cot inverse of 1 plus sigma k is equals to 1 to n 2k. So now this value, what is this? Here already we simplified cot inverse of 1 plus sigma k is equals to 1 to n 2k value will be this numerator here, tan inverse of n plus 1 minus tan inverse of n. So now you take this one is that a sigma n is equals to 1 to 23. N is equals to 1 to 23. Tan inverse of n plus 1 minus tan inverse of n. So this one is the after substitution. Now what is meant by sigma? Sigma is nothing but a sum of all the different terms after substituting n value. N is equals to 1, 2, 3, 4 and so on up to 23. So now you substitute in this one, that value will be after substituting. N is equals to 1, that gives the first term, tan inverse of 2 minus tan inverse of 1 this is the first term, plus second term will be n is equals to 2, you substitute tan inverse of 3 minus tan inverse of 2 so this one is the second term. Okay, plus n is equals to 3, you substitute tan inverse of 4 minus tan inverse of 3 okay, so and so on, plus like up to this one you have to substitute. The last term will be n is equals to 23, you substitute, that value will be tan inverse of 24 minus tan inverse of 23 so this one is the last term, this is the 23rd term. Okay, Now after substitution, you can observe that one particular series plus tan inverse of 2 minus tan inverse of 2 cancel, plus tan inverse of 3 minus tan inverse of 3, like tan inverse of 4 up to this one is the cancel. What is the resultant value after the cancel? That will be equals to the remaining terms will be here in the last term tan inverse 24 is the remaining. In first one is the minus tan inverse of 1 is the remaining. So now here you write it tan inverse of 24, tan inverse of 24 minus a tan inverse of 1. So now this one is in that which formula? Tan inverse x minus a tan inverse y. Tan inverse x minus tan inverse y will be tan inverse of x minus y, that is 24 minus 1 whole divided by 1 plus x into y, that is 24 into 1 is the 24. So this value will be equals to tan inverse of 23 whole divided by 25. Okay, so this one is the value. This one also you can write as cot inverse of 25 by 23 also you can write it, 25 by 23. So this conversions will be depends on the options. So now you see that in that given question, what are that options are given? Here one thing is there, outside cot is there. Now you see here this total value is that a cot of sigma n is equals to 1 to 23. So now you take that this one will be outside cot is there. So therefore cot of, so what is that resultant value? That will be in terms of the cot will be cot inverse of 25 by 23, 25 by 23. Suppose outside tan will be there, you have to take the tan of tan inverse. So this value will be equals to 25 by 23 is the correct answer. So I hope that everyone is clear this problem. So your answer will be 25 by 23 is the correct answer. So check this one, 25 by 23, 25 by 23. So your right answer will be second option is the right answer. Okay, so next one more question we'll discuss in this same model. Say what is the next question? The next question will be this one. So all of you see this one is also it is a same procedure, but you should be very careful while finding the general term. See in this one, so all the numerator terms, observe it. First one is that 4, next is the 6, next one is that 8. Okay, so these are the terms. Now you write it all these terms first. This one will be nothing but 4 comma 6 comma 8 comma and so on. So very clearly these are in that arithmetic progression. These will be in that arithmetic progression. What is the nth term in that arithmetic progression? Tn is equals to, this one is a plus n minus 1 into d, n minus 1 into d. By substitute, a is the first term, d is the common difference. So this one is that 4 plus n minus 1 into 2, n minus 1 into 2. Finally this value will be 2n plus 2. 2n plus 2 is the first term. And the same way you take that in denominator 1 plus 3 into 4, 1 plus 3 8 into 9, 1 plus 15 into 16. So by observing, first you take that 3, first 3 and 8 and 15 you take it. So if you take that 3, 8 and 15, so you see here by observing this one, you can say this value will be equals to what? So here you can write this value will be 3, 3 and 8 and 15. Okay, so comma and so on. These are by observing that directly first time the common difference is not the same. What is the common difference of these two numbers? That is that 5. The common difference of these two numbers is that what? 7. Right? By observing the next number will be, how much will be the next number? Here is that adding the 7 plus 15. 7 plus 15 will be 22. So here the next number will be 22. The second next number will be 22. See, check this one. Here 8 plus 7, and the next one is that, sorry, this one is that 15 plus 9, because of the 2 is that, here is that 2. So this common difference is that what? 2. So what is the next number with the common difference is that 2? 9. Okay, so this is also 2. Next number is that what? 11. Okay, the next number is that 11. So now this number will be adding of these two. 15 plus 9. 15 plus 9 is equals to how much? That value will be equals to 24. This value will be 24. This value will be 24. Next, by adding these two, we will get the next number. 24 plus 11 is equals to what? 35. So the next number will be 35. So here is that very careful to find out this one. Actually, one method is there in progressions. In any series, the common difference second time is same. The difference of the numbers is the same in the second time. Here this is the first time, and first time the difference of the successive numbers is 5, 7, 9 and 11, and this is the second time. When second time is the same, that nth term will be Tn is equals to, that will be in the form of quadratic expression, a into n square plus b into n plus c. It is a very important concept. You can see this one again in the progressions chapter or sequences and series. So this one will be this one. Suppose a third time is the difference of successive numbers in third time is the same. It gives the cubic equation. Fourth time biquadratic equation. So how can we find here the coefficients? What are the coefficients in this one? A, B, C are the coefficients. How can we find this one? Now Tn is equals to an square plus bn plus c means, if you write that n is equals to 1, T1. T1 is that what? First term. What is the first term in this one? 3 is the first term. Okay, so now you write it. N is equals to 1. If you write it, that value will be a plus b plus c. A plus b plus c. This one will be equals to T1. T1 is equals to what? 3. So let it be, this is that equation 1. Next, n is equals to 2. If you write it, that is T2. T2 value means a into 4 plus 2 into b plus c. So this one is that 4 into a plus 2 into b plus c is equals to, this is that 8. Let it be, this one you take as that 2. Equation 2. And next, n is equals to 3. So why you take that n values are 1, 2, 3? Because how many unknowns are there in the Tn? 3 unknowns are there. One is that a, next is the b, next one is the c. So that n values, how many n values will be substitute, that depends on the number of unknown terms in the nth term. So here 3 unknowns are there, a, b, c are there. That's why here the next one, put n is equals to 3, that value will be 9 into a plus 3 into b plus c is equals to T3. T3 will be nothing but what? 15 is that third term. So you have to be write it. This one is the 15. So let it be. This is that third equation. Now solving these equations. You see this one will be. You can write that how you can solve this one. 2 minus 1. So subtracting the first equation from second equation. Now that value will be 4a minus 3a. 4a minus a, that is that 3a, plus 2b minus b, that is that b. C and c will be cancelled. 8 minus 3 is that 5. So this one you take as that equation 4. And next same way you can write that 3 minus 2. 3 minus 2. 3 minus 2 will be 9a minus 4a is nothing but a 5a. 3b minus 2b will be equals to plus b. C minus c will be cancelled. 15 minus 8 is equals to 7. So this value will be equals to, this is let it be equation 5. Again solving fourth and fifth equations. So you can write that 5 minus 4. 5 minus 4. 5 minus 4 means 5a minus 3a will be equals to 2a, plus b minus b will be cancelled. 7 minus 5 is equals to 2. From this one, a, therefore a is equals to 1 is the value. If you know that a value, if we know that a value, this one substitute any of the 4 and 5, you can get that b value. So you substitute in that 4, from 4, b is equals to, this value will be 5 minus 3. 5 minus 3 will be equals to 2. So b is equals to 2. After you know that a, b values, substitute in any of that 1, 2, 3. I will substitute in the first equation. So and c is equals to, that value will be 0. C is equals to, what is that value? 0. C is equals to 0. Therefore, what is that nth term of that one? Nth term of the above series. So which series? That is nothing but 8 comma 3 comma 8 comma 15 comma 24 25. So this one nth term will be Tn will be equals to, that will be what I told, the formula an square plus bn plus c. A value is that 1, b value is that 2, c value is 0. That value will be equals to n square plus 2 into n. Okay, so now this one we can write that n into n plus 2. You can write this value will be this one. Now, so you got it that what will be the nth term of the series 3, 8, 15, 24 and 35. Similarly, that next by observing that here you have that 4, you can take that 4, 4 and 9 and 16 like this one. So what are the values? What will be the nth term? What is the nth term of the numbers? So that means you can be find 4, 9 and 16. 4, 9 and 16. 4, 9, okay, and 16. So you see this one is comma and so on. By observing this one, so that nth term Tn will be equals to n plus 1 whole square. So you see n is equals to 1 if you write that, 2 square is the 4. N is equals to 2 if you write it, 3 square, that is the 9. N is equals to 3 if you write, that is the 4 whole square, 16. So this is the value. Now after this one, therefore, what is the general term? What is that general term? What is the general term of TR? What is that TR value? General term TR is equals to, now you see here this one you can write that tan inverse of what is the numerator nth term? 2n plus 2. So nth term numerator, nth term will be 2n plus 2. So there you write that r, n is equals to r. So this one we can write that 2r plus 2 whole divided by, next one will be the 1 plus here the first factors are 3, 8, 15, 24. That value will be n into n plus 2, n into n plus 2 into next factors nth term will be n plus 1. Sorry, here you write that replace n with r, n with r. You see this one is replaced with n with r. That is that this value will be, you can write r into r plus 2, r into r plus 2 into the nth term of the next factors will be n plus 1 whole square. So you can write that r plus 1 whole square, r plus 1 whole square, right? So after this how you can be write this value, that is equals to tan inverse of, you see, 2r plus 2 whole divided by, okay, 1 plus, here I will write that r plus 1 whole square as r plus 1 into r plus 1. So I will write that r into r plus 1, and next I will write that r plus 1 into r plus 2, r plus 1 into r plus 2. So now why you are right splitting this value? So now you see, here is that by taking this one and by taking this one. So what is that product of these two? This one is that r square plus r. So what is that a product of these two factors? R square plus 3 into r plus 2, right? Now by observing the difference of these two factors, the difference of these two, r square plus 3r plus 2, you see here r square plus 3 into r plus 2 minus of r square plus r, right? Now you see in this one, by difference this value you can write that 2r plus 2. So very clearly numerator is the 2r plus 2. So that value you can replace with this expression. Here 2r plus 2 you can replace with r square plus 3r plus 2 minus of r square plus r. So now you can write it, this value will be equals to tan inverse of the numerator can be replaced with r square plus 3 into r plus 2 minus of r square plus r whole divided by 1 plus this one is r square plus 3r plus 2 into r square plus r. Now this expression is very clearly in the form of tan inverse of x minus y by 1 plus x into y. So now you can write this value will be equals to tan inverse of x minus tan inverse of y. So this one is a tan inverse of r square plus 3 into r plus 2, 3 into r plus 2 minus a tan inverse of this one is a r square plus r. So this one is a simplified value of general term. So now you see, you want that sum of the infinite terms or any other value, sum of the infinite terms. So first you find out that sum of the n terms. Sum of the n terms already in previous questions I explained how to find the sum of the n terms. You apply the sigma to the rth term, that is the general term. So sigma tr, r value will be equals to 1 to n, r value 1 to n. If you apply that sigma, now first r is equals to 1, that will be the first term. Now we will be discuss what is the first term. Tan inverse of r is equals to 1, you write it 1 plus 3 plus 2 is the 6, right, minus tan inverse of 1 plus 1 is that 2. So this is the first term, this one is the first term, plus r is equals to 2. If you write that 2 square is a 4, 4 plus 3 2s are 6, 4 plus 6 will be 10, 10 plus 2 is the 12. So tan inverse of 12, tan inverse of 12 minus tan inverse of, here this one will be not r square, this is that r only, this is that r only, plus this value will be r. Okay, r square plus r, that is that 4 plus 2 is the 6. This value will be tan inverse of 6, tan inverse of 6. This is the second term, plus what is the third term? Tan inverse of, third term means r is equals to 3. If you write it 9 plus 9 18, 18 plus 2 is the 20, tan inverse of 20 minus that one is the tan inverse of 12. So by observing this one, the next tan inverse 20 minus tan inverse of 12. So here in the second term, what is the first term is there, that in third term the next one is also the same. So now you can write it, this one is that plus, okay, and so on and so on. What is that last term? That will be plus tan inverse of n square, tan inverse of n square plus 3 into n plus 2, okay, minus tan inverse of n square plus n square plus n. Okay, this one is the last term. By substitute r is equals to n. Now by observing all these, now you see in that terms, plus tan inverse of 6 minus tan inverse of 6 cancel, plus tan inverse of 12 minus tan inverse of 12, tan inverse of 20 cancel, and the same here this one will be cancelled. What are the remaining values? What are the remaining values? Remaining terms will be in the last one tan inverse of n square plus 3n plus 2, and in the first term minus tan inverse of 2 is the next one. So the resultant value you can write it, that is equals to tan inverse of n square plus 3 into n plus 2 minus tan inverse of 2 minus tan inverse of 2. Okay, now this is that word sum of the n terms. Sum of the n terms, after finding, you take that limit n tends to infinity or n is equals to infinity. So sum of the infinite terms s infinity is equals to limit n tends to infinity, sigma r is equals to 1 to n t suffix r. So this one is the value. Now this one already you got it, sum of the n terms in the above step. So you put n is equals to infinity, that value will be tan inverse of infinity minus tan inverse of 2, tan inverse of 2. You know what is the tan inverse of infinity value? That will be equals to pi by 2. For what angle the tan is the infinity? 90 degrees. Minus a tan inverse of 2. Minus tan inverse of 2. You know this one is in the formula pi minus a tan inverse x. Pi minus tan inverse x, you can write that cot inverse of x. So cot inverse of 2. So your answer will be any one, pi by 2 minus tan inverse of 2 or cot inverse of 2. Now you check that given options. What is that given one? Here you see one by one all the options. What are that one? Here tan inverse 2 is there and the cot inverse 2 is there. So actually the last what we get it the value, that value will be, that is the cot inverse of 2. So your right answer is that cot inverse of 2 is the correct answer. First option A is the correct answer. Option A is the correct answer. Option A is the correct answer. So I hope this problem is very clear and a very important question for mains or advanced question. This one is a mains problem or advanced question. So it is a very important model. It is a very important model. So please all of you do the practice thoroughly till you are understanding the concept. Okay, so thank you for watching this video. If you like, please share and subscribe the channel.